So what I'm also doing is I'm also recording this part too, so you can always go back and look at it. All right, so on number 19, your first parameter is saying that you have all values of x that are greater than or equal to 0. That tells me that I'm going to have either a first or a fourth quadrant problem. Since there are no values I shouldn't say no values, but there are no restrictions on the y values, I'm going to kind of dummy out a graph that looks like this, just to start with. I'm just going to start with that. SMRT. And I know I'm going this way. Now I cover and solve. X-intercept of 3, y-intercept of 2. Connect them. And I know that it has to be greater than 6. So 0, 0 is false, so it's going outward. So I'm going that way right now. The next one I have x-intercept of 3, y-intercept of negative 4.5. And don't forget, it continues. A lot of people stop there. It continues because it's going through all values of x. 0 minus 0 is smaller than 9, so it is working its way into here. Bless you. And next one I have is x plus 5y is 20. So I have an x-intercept of 20 and a y-intercept of 4. Across here. And 0 plus 0 is smaller than 20, so it's working its way back inward. So right now, I have found this bounded region that has 4 sides. I'm looking at those 4 spots. What I need to do is figure out the ordered pairs of all the intercepts. 3 of them are real easy, because 3 of them are on axes. I've got 0, 2, 0, 4, and 3, 0. You agree on that?
Yeah.
All right, now I have to figure out where the intersection of these two met. And remember, when you're trying to find the intersection of 2 lines, it's nothing more than solving a system of equations. So in this case here, what we have to do is set up and solve the system. This one kind of sets you up for a couple of ways of going about it. I think the easiest way to do this is solve for x in the bottom one and use substitution. So now I know that 3 times quantity 20 minus 5y minus 2y is 9. Remember, like we discussed yesterday, when you were solving systems with these things, disregard the inequality symbols. Don't worry about them. All you gotta do is just solve them out. 60 minus 15 minus 2 minus 17 is 9. Y. 51 is 17y. Y is 3. Okay. So the y value of this ordered pair is 3. In order to figure out what the x value is, I just resubstitute in. I know that 20 minus 5 times 3 is 5. And there's my ordered pair. From that, I just test all 4 of those points in my objective function, the one that was given to us, to figure out where I get a maximum and a minimum. Here I will have both a maximum and a minimum because I'm bounded at all 4 sides. There's no open top, there's no open bottom. Okay. What else?
Well, how did you find out it was 5?
I just substitute, since 3 is y,
Yeah.
I just substitute right back in here.
Oh, you just, okay.
20 minus 5 times 3.
I got you.
All right. Number 20, you said?
Yeah.
First quadrant problem? 20. First one's a little weird because you have that negative x plus y is 0. Basically, that is the line y equals x. Slope of 1, and it's just going like this. All right? That's the line y equals x. Now, in order to tell, bless you, tell how that's shaded, what I'm going to do is just pick any point that I know that's not on that line. I'm going to say that the number ordered pair 5, 0 isn't on that line. Do you agree?
Yeah.
Is -5 plus 0 greater than 0?
No.
No. So it's false on this side, so it means it's true up here. Okay? So right now I have that wedge. I'm looking in that wedge. And then I just continue. X-intercept of 2, y-intercept of 4. They intersect right here. Is 0 plus 0 greater than 4? No. So it's going outward. So I'm still in this wedged area. And then x-intercept of 6.5 and y-intercept of 13. Zero plus 0 is smaller, so it's coming inward. So I have this spot. So what happened now is that I have bounded again in 4 spots. I have those 4 ordered pairs to work with. 2 of the ordered pairs lie on the y-axis, so it's rather easy to get their coordinates. 0, 13, 0, 4. Are you okay with that? The next one is the intersection of the first 2 equations. Well, I'm going to use substitution again. It's really easy with this problem because y equals x. Do you agree?
Yeah.
Good. So then that means on this first equation, I'll put this on 2 screens, it's easier to see. When I use substitution, I have 2x plus x is 4. So 3x is 4, x is 4/3. What's y then? 4/3. So there's one set, 4/3, 4/3. That's here. And then I do the same thing with the other equation. Y is still equal to x with, now it'll be 2x plus x is 13. So 3x is 13, x is 13/3, which means y is 13/3. So my other ordered pair is at 13/3 and 13/3. Yes, I know that the decimal value, the fractional value here kind of is a pain to substitute back and forth. But I'm going to go out on a limb and assume you can probably figure out by looking at it what one is going to give you your maximum value. Probably do 13/3. I mean, just from looking at it when you're multiplying things out, 10 times 0, whatever. 10 times 0, not going to help me any at all. 3 times 13, though, it gives me 39. So as long as both of these guys are larger than 39, you're all right. It's just a matter of just substituting in. You can get decimal equivalents to give you guys a rough idea. Because all you have to do is identify the maximum and minimum value. You don't have to say what that value is. I think it says that in instructions.
Oh, so you don't have to actually figure out what it is.
Well, you have to figure it out, but you don't have
Well,
to.
you don't
You
have
have to
to-
state it, you
yeah.
know. But you kind of do anyway to
Yeah.
figure it out.
Yeah.
Do you want me to walk you through how to substitute in? Or are you okay with that? I'm open. Hey, Spurs, how are you?
Hey, just saw your wife.
Oh, I know it's
I'm
crazy, isn't it?
punishing kids, so.
Yeah, you gotta punch a lot of her kids.
Yeah.
That's it. What? Yes, she's a science teacher.
Wait, what?
Oh, she was allowed to sign
Yeah.
Wait, what is she doing?
Science. Her name is Mrs. Murphy. Go figure. Yeah.
Wait, what sciences does she teach?
She has an earth science class in here.
Where is her class?
In the science room. Wing.
You don't even know where it's
Freshman
going.
size.
It's that way.
Is it freshman thing?
I think so, yeah.
Their science is
I'll just call it blonde.
Wait, is she new?
Yeah, she just started here this year.
Okay, that's what.
She taught at Marengo for
Marengo.
9 years at the high school.
No. Why would you teach that?
That's why I asked you if you went to the high school. You didn't go to the high school, so you don't know her.
My friend does though.
There you go, she probably had her. Or he probably has
I was
her.
in high school.
For a softball game?
No, I actually lived
She's a compulsive
I
liar.
know she is. Now you guys kind of see where you messed up as far as solving systems of equations. So fix these for tomorrow. Let's build this into today's stuff. So today we start with. Today we start with word problems. Now, what I have done. Oh yes, this. Let's take a look at what this means as far as word problems are concerned. And how I want to go about today's lesson, ladies and gentlemen, how I want to go about today's lesson with the word problem parts is to help you guys decipher the language that they are speaking as you go through these. All of these constraint style problems all have some sort of constraint. They also have some sort of objective. There's something you're trying to solve for, whether that be profit, hours, things like how many things can you have, things of that nature. And it's pretty literal as you get into the problems what they're looking for. So let's look at this first one that's dealing with the gift basket. All right, so you're making a gift basket for your mom. That's very, very nice of you. She's an avid reader. You're going to buy her both hardcover books and paperbacks. You have $80 to spend on books. Each hardcover book is $24, and each paperback is $8. The basket will hold at most 3 hardcover books or 7 paperback books. Find the maximum number of books you can include in the basket. What is your objective? Maximum number of books, okay? So your objective here is to find the maximum number of books. So if I'm looking at the maximum number of books, I'm looking at is my constraint. Remember we say that's the C value. The 2 types of books that we're getting are hardcover and paperback, right? H and P. There's my objective function. I want to figure out what is the largest total number of books I can purchase to fit in there. Make sense? Told you, the objective function is pretty easy to find. Now you look in there and you start to find some parameters. Did you notice they talked about the total amount of money you have to spend? Now, if you have only $80 to spend, can you spend more than that $80?
No.
Can you spend up to $80? Can you include spending $80? Is that a less than or equal to or greater than equal to?
Less than.
Very good, very good. Now, when you're purchasing books, does it say how much each one of them costs? Since this is a money figure here. How much are the hardcover books? There's your first constraint. You are bound by that value to be for that equation for your money. Now, it also said that the basket can hold at most a certain amount of things, right? So it said it can hold how many hardcover books at most?
3.
3 of them. So is that a less than or equal to, greater than or equal to, less than or greater than? Less than or equal to, very good. That's the most it can hold. Can it hold a negative of these? No. So it has to be greater than or equal to 0. See where I'm going with that? You just parameter your H values. Same thing with the P value. How many of those could you have? 7 of them. At most again, right?
Yeah.
And of course you can't have negative. You just did it. You did it. You just did that. You did it. You wrote all your constraints out. Now you have to just graph it and find out the intersections. So they put a separate sheet to put everything all together. When we do these things, what I want you to remember is, as you're labeling these things out, we use H's and P's. You're going to use different variables because it makes sense within the word problem itself. Just when you start to make your graphs, just label them so you know which one's which. It does not matter, because as long as you're consistent, you're going to get the same values. If you call the H's Y's and P's X's, as long as you're consistent, you're fine. The problem comes in sometimes people switch them by mistake, and they get weird intercepts and it doesn't work. So that's why I usually just, the first variable I read or I write down, I use that as the x-axis, and then second one is the second axis. You just go from there, okay? Now, do you guys all agree that this is a first quadrant problem?
Yeah.
Yeah. I am bound by the H value can't be any more than 3. So it's somewhere between 0 and 3. Same thing with the P value, it has to be somewhere between 7 and 0. So right away, I'm within that rectangular shape. Now it's just a matter of cover and solve.
Alright, so
P-intercept is,
10.
H-intercept is,
4. No. Nope.
you have the
6.
calculator in front of you, right?
Oh, crikey.
3 and a third.
3 and a third, okay? So somewhere out
We're
here.
all over.
And we connect them. Now, within those parameters, I have to check this one. Is 0 plus 0 smaller than 80?
Yeah.
Yeah. So it's somewhere in here, right? So what you've just done is you've created
Is that a
5-sided figure.
Oh.
So there are 5 intersection points.
Killed him.
You already know 2 of them.
0?
3, 0. Oh, I forgot about that. You know 3 of them. 0, 0, and 0, 7. Do you guys agree?
Yes, sir.
Now, in order to figure out these ordered pairs is where the 2 lines intersect. Well, you know one of those lines intersects because it's x equals 3. So I know that the x coordinate here is 3. All I gotta do is substitute in. What's 3 times 24?
8. Wait.
Other way.
3 and a third.
72.
72, okay. 80 minus 72.
Is
3 and a
What's 8 divided by 8?
1.
There's your ordered pair. I do the exact same thing with the y value for 7. 7 times 8 is how much? 80 minus 56.
24.
24 divided by 24.
1.
So you now have 5 ordered pairs to check with your objective function. 0, 7, 1, 7, 3, 1, 3, 0, and 0, 0. Sorry, go ahead. No, go ahead, please.
Oh, I got it.
It doesn't matter the order in which you list out your ordered pairs, where you start on your shape or whatever you wind up with there. It doesn't matter. But remember, all you're doing for your objective function is h plus p. Well, what's 0 plus 7?
7.
Where does your maximum refer?
1, 7.
1, 7. Now, what does that mean in terms of the word problem then?
100.
Perfect. 1 hardcover.
Sometimes we only have 7 paperbacks or 3 paperbacks.
Up to, including, at most 7.
Game on.
And that's what we do. It's at most 7 is what it said. At most is it less than or equal
But I thought it couldn't have more than 7 paperbacks.
Yeah.
to. We don't.
Oh,
We don't.
oh.
Yes, it can hold at most 7. At most means it's including 7.
But then
We
isn't
have
there
7
one hardcover
Yeah,
in there
there's
too?
one, yeah.
No. It's saying that's I don't know why the basket says that. It says that it can hold up to 7 paperbacks or up to 3 hardcovers.
But it does say.
But it says or.
Right. So it's holding 7 or 3 of these. So it's got a total of 7 of these and just one of those, and that fits into the parameters fine.
So it's and slash.
I thought 7 paperbacks equal 3 hardcovers.
No. That's just saying that it can hold. It can. The way that it's built, I don't. Yes.
So why did I do that? Is it 160?
Because that's how we roll. Okay? Let's try the next one. Let's just continue. You are now sewing doll clothes because it's a lucrative business apparently.
It's a way to
You make money.
probably
You are sewing doll clothes to sell at a craft show. Party dresses take 2.5 hours to make, while casual sets only take an hour. You make a profit of $9 on the party dress and $4 on the casual sets. If you have no more than 30 hours to work, and you can make at most 15 outfits, how many of each kind can you make in order to maximize your profits? So once again, what is your objective? Whoa, 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 whoa. You're giving me equations. I'm just asking you, what's your main object here?
Get money.
To make money. Maximize profit. Okay? It's that specific. What's your goal? Make money. Alright, maximize profit. So now you go back into the problem, and where does it talk about profit? Alright, so you make $9 on the party dress, and was it $4 on the casual one? I know I'm using the little c for the variable, and I've always been using that large C for the objective function, because that's how we always write these out. So don't worry, there's not two C's here, okay? So your objective, your goal, is to maximize your profit. So now you go back and you think about the problem. The problem itself was discussing two things. It was talking about total amount of hours you have and how many you can make. What was the total amount of hours you have to work? 30. So your total amount of hours you have is 30. Does that include 30?
Yeah.
You work up to 30, not more than 30, so it's a less than or equal to. You agree?
Yes, sir.
How many hours does it take to make a party dress?
2.5.
How many hours does it take to make a casual? 1. So 2.5 party plus 1 casual. Do you agree on that? What's my other one deal with?
The amount of dress.
15 outfits, okay. Does it say I can make more than that or less than that? Or is it at most, it's also perfect. And what are the two things that we are making? B and C. Can I make negative dresses?
No, sir.
Well, you couldn't for.
No, but then,
It just changed shape. It doesn't.
Yeah, it's a physical change.
yeah.
It's a physical change. It's still there.
Do we have to put
Get 'em.
do we have to put the P's greater than 0 and the C's greater than 0? Can we just assume that it's going to be a first quadrant problem?
A lot of these, I don't think there's really any of them that we come across that don't wind up being first quadrant problems. There are times where you are bound, like the problem we just did earlier, how you were bounded between 0 and 4 or 0 and 7. That does come up, so it's not a bad habit to get accustomed to, just of labeling out, so that way you don't get lost of where you are to stop. To be honest with you, I don't think we have any of them that go negative. Don't quote me on that, but I don't remember seeing one, and I've done multiple of these over the past few days. So now, what do we do? Graph it. So let's get another sheet. First quadrant problem. I'll label my P and C. I have x-intercept on the P for what? 30 divided by 2.5 is 12, I believe. 12 and 30. Is it moving inward or moving outward?
Inward.
Inward.
sir.
Inwards. Inward, Mr. Chair.
And then the other one has intercepts 15 and 15. Give me scrunchy face, you okay? All right. Yes.
Such a.
I covered and solved. I got the C was at 30, and I took 30 divided by 2.5.
That makes sense.
So we got 15 and 15.
I don't even know.
Is it moving inward or outward on this one? It's moving inward again. So you have now just bounded a region again. Right there. You have 4 sides to that region, so how many points of inflection do you have? What is the only one you have to do a little bit of work to solve for? Yep. So in order to solve for this one, that's where these two lines intersected one another. Okay? That's where these two guys intersected each other. And if you look at them, the way that they were written out originally, it's setting us to solve the system of linear equations by subtraction. See how we have the same coefficient with the same sign with the value of C? I don't think it's on your phone though. Let's put that away, because when you come up later and going, I don't know what I'm doing, I'm just going to say I'll text you later. Okay? There's a time and a place, and right now is neither of those. So on this case here, I'm going to subtract the 2. So 2.5 minus 1 gives me 1.5 equals 15. What's the value of P? All I'm doing here, since I have the same coefficient, same sign, I'm subtracting these two equations. Give me that. So that means my P is 10, C is, well, 10 plus what is 15? I just resubstitute back in, solve it. So what happens here is you have those 4 ordered pairs now to work with. 0, 0, 12, 0, 10, 5, and 0, 15. Our objective function was 9p plus 4c. So you have 0, 9 times 12, 9 times 10, plus 4 times 5, and then 4 times 15. That's 108, and this is 110, and that's 60. How many of each are you going to make? 10 and 5. 10 party dresses and 5 casuals.
What was the ingredient? Oh, 10 party?
Because remember, that's how our ordered pairs went. The x, the first coordinate was our value of p, and the second was the value of c. Now, Ryan, if you're saying, can you write them other ways around? If you wrote yours and kept it consistent with the p values going up and down and the c's going the other way, your ordered pair would have been 5, 10. And it would have meant the same thing as long as you were consistent. Yes, ma'am?
Okay, I know we just did the graph and everything to tell us the answer to this, but if you make 9 on every party dress and 4 on every casual outfit, it takes an hour to make. It doesn't add up where making more casuals you make more profit because you, and out of 2 hours you make $8 profit, and out of 2 hours you make $9 profit in a party dress.
This is over the total amount of time that you have.
Oh, so it's.
This is the total amount that you have, because it said you had up to 30 hours, I believe, to work?
Yeah.
Yeah.
You have up to 30 hours. You're thinking just in one snapshot of time frame. Yeah, because in 2 hour time, it's going to be different. But since you're working up to 30 hours, that's how that works out.
Oh.
So if you had, this answer would be different depending upon the number of hours that you have allocated to work. All right?
I made $110.
That's a pretty crummy job.
Minimum.
Yeah, that's a pretty crummy part-time job right there. Okay.
I did, yeah.
Let's look at that last one, because I neglected to put the chart in there. I apologize. There's a table that's supposed to be there, and I forgot to put it in there, so I have to show you what the table is.
No, it's just big.
Yeah.
It's got a lot of curves.
So there's a table for this, and in my haste of making these sheets, I forgot to, I cut it off too fast. Trying to make it sweet. The table that goes with this problem, you had a little bit of room to put this in here. You have machine hours. Because you don't have the chart yet. Like I said, when I cut and paste these things, I forgot to put this on here. You have the breakfast bar. The granola. And it's a maximized profit. Okay.
What's the third column?
Oh, sorry, maximum hours. Sorry about that. So here's what happens. You have a company that makes granola bars and breakfast bars. Each case of breakfast bars, you make 40 bucks in profit. Each case of granola bars, you make $55 in profit. The table below shows a number of machine hours and labor hours it takes to produce one case of each type. What is the maximum of each of them you would get to maximize your profit? So basically we're looking to figure out how many cases of each do we get to get the maximum profit. All right? So as we start with the problem again, you want to maximize profit. So if I'm going to maximize profit, what's the profit that I make on the breakfast bars?
40.
What's the profit that I make on granola bars? So I know that 40B plus 55G is my objective function. Okay? The next two equations, or inequalities, are laid out for us. One of them talks about the maximum number of machine hours. The other one talks about the maximum number of labor hours. So it basically tells me 2B plus 6G is less than or equal to 150. The maximum hour jack. And then with labor hours, 5B plus 4G is less than or equal to 155. And you can't have negative boxes of granola bars. You now have enough information to plot and graph that. You also have two more of these on the back. That's what I want you to finish out for tonight.
All right.
The next two problems that are on there, they may take a little bit longer than the ones we just did, but that's okay.